Okay, so let's get a few logistic things out of the way. So welcome back to Intro to Backend. This week we'll be covering images, so how we're storing images in a database. And in fact, this week is the last week of lectures. So kind of bittersweet, but hopefully you guys had a fun semester. So a few announcements before we get started with class. Earlier this morning, I made an ed post releasing mentor preference form. So what this means is, for Hack Challenge, all of you are going to be assigned a mentor. And a mentor is going to be everyone in the backend sub-team on app dev. And on app dev, we have very, very wonderful people that are going to be open to helping you with your backend projects, but also open to things like coffee chats and anything in between. So highly recommend you just kind of look through the video that we uploaded, just see who's potentially going to be your mentor, and if you have any preferences, you can tell us through the form as well. Also, later today or potentially tomorrow, we're going to make a post on what you have to be doing with your mentors. This is going to be mandatory, right? So this is going to be the midpoint check-in, the final submission, and a few things along the way, and it's going to be part of your grade. So make sure you keep an eye out for that ed post. Lastly, you're going to be using Git for your projects. The final submission is going to be a GitHub project link. So it's very critical that you all know how to use Git. And Kate made a post earlier today on how you can use Git. There's actually an optional demo that was uploaded on YouTube, so you can check out the first bit of that. And also there's a cheat sheet on how to use Git. So you can take a look at that as well. And yeah, again, this is the last week of class, so very sad. Okay, so today we're going to be having 2 guest lecturers like we did last week. We have, do you want to come here? We have Joyce, who's a sophomore, and Maria. Do you guys want to introduce yourself?
Hi, I'm Joyce. I'm a sophomore. I study CS at UConn.
Hi, I'm Maria. I'm a freshman. I'm studying CS, and I'm not graduating in 2024.
Oh, oops, sorry.
It's all good. Yeah. I was supposed to.
Yeah, so Maria's graduating in 2025, I believe. So they'll be taking over today. So yeah, let's get started with images.
Cool. Okay, so obviously in this class, you guys already talked a lot about storing data, and particularly storing data in like relational databases. And what's nice about this is, if you visualize it as a table, you have a bunch of columns that store different types of information. And each of these columns, store particularly information of a different type. So for example, in the ID column, you have like integer values. In the name column, you have text values, right? But if you want to put images into your database, it might not be like very apparent from the get-go what kind of type or like how you might actually like store these images in the database, hence the question mark on top of the images column, right? So today we'll introduce like 3 different types of like methods that we can potentially use to store these images. So 1, we have storing these images as a blob. 2, we have storing them as a local path file. Or 3, we directly store like an image URL in our database instead. So I'll be passing off to Maria to first talk about blobs.
So one way we can store an image in our database is as a blob. A blob is a binary large object. It's basically that entire image, but if it was expressed as binary data, we can really store anything as a blob. You can put an image into a blob, you can put a video into a blog, a TikTok, anything you want. And if you were to store it into your database, it would look something like this. This is a blob as a string. It kind of looks like a mess, garbage. Can't really do much with it. The benefits of storing your image as a blob, it's pretty easy because you just kind of stick it in there, and that's kind of it. Because blobs are kind of expensive to store because images have a lot of data in them. Like in videos, they have a lot of data, so that's sort of a lot of things that we need space for, and space is kind of expensive. And also, like, it's expensive to have all of the space for that, and it also is expensive to like back up that sort of data. And it's also to have so much data, it's very slow to back up as well. And additionally, oh wait, where's that? So this is not structured data, and databases are designed to store structured data and like be very compact, but this is not that. So it's not really the best way to store an image. So there are two other ways that we could do it instead.
Cool. So I'll be talking a little bit more about how you can store a file path to access your image instead. So first, we can talk a little bit about what a file path is. So a file path is essentially like the location in your computer where like a folder or a directory or like a file is located. So you can split a file path into like two different ways of thinking about it. First, you might have a relative file path, which is essentially kind of describing the location of what you're looking for relative to where you currently are. You might also have an absolute file path, which is essentially describing the location, but instead starting from the root directory of your computer. So here are a few examples. So start with an example of a relative file path. If you're looking for the Pikachu PNG image, and we're currently in the amazing app folder, the relative file path would be going to static and then the Pikachu picture. So for an absolute file path, if we're looking to access app.py, we first have to start like all the way at the very root in terms of the user directory, and then go all the way down into the app.py file. So as you've learned previously in this class, servers are computers too, which means that we could probably store an image locally on one of these servers, since this data can exist outside of our code and our database. So the way we would do this is to create a post route that would directly access and upload this image to save it onto one of our servers. And here's like a visual sort of representation of what that might look like. So the top folder there would be like the root directory of the machine. Then you can like specify a directory for images that will like take the images that a user uploads, so the images kind of live there and can be accessed. And with this visual representation, you see that it makes the way that we store the image in the database a lot cleaner. So instead of like literally having a huge blob of text in there, we would only store the image path itself. And so obviously this comes with a few benefits. Comparing it to the original method of storing a blob, we obviously see a lot of benefits in terms of speed as well as scalability. But then second of all, when you store an image as a blob, as Mario mentioned, it is like binary data. So you might need to have like a secondary process to actually process that data and then turn it into an image. Rather than like with this method, since we're storing directly the file itself, we can access the image directly, which is pretty nice. But then secondly, image backup becomes asynchronous. So for example, maybe if you think your database needs like more frequent backup, or you think like your image backup is like really slow, well, good for you, this image backup can be like independent. And then finally, like with the visual example that we saw in the previous slide, it's clearly a lot cleaner and prettier. But of course, this method is not the best method, or else it would be like the last thing we introduce. So, if you like have a small app and you want to like store things locally, you can probably get away with like storing all of those images locally on a server. But like as the number of images increases, you probably don't want to do that locally anymore. If you're like, oh, what if I like spin up another server to store some more images? Well, then you run into another problem, because then that server won't be able to access the images that were already stored on your first server, which also naturally means that like if one of your servers goes down, anything that was like stored on that server will become inaccessible, which can definitely present a problem to your users. And then finally, maybe you want like maybe you have like a lot of different servers for your app. You want like one server to like specialize for something. Maybe like one server specializes in like running a web app. So you don't want to like further burden that server by adding file storage like responsibilities to it as well. But if you do this, then you run into problem 2. So you won't be able to access images across the board, which is also not optimal. So naturally, this presents us with the solution of like, oh, what if we like outsource this like stupid file storage job to like something else, which is what we'll be covering next.
So like Joy said, we can sort of outsource this responsibility of having to store the images locally. We can use a cloud-based storage using free and paid services that already do this for us, like Microsoft, Google Cloud. The one that we're going to be using for this class is Amazon S3 or AWS. And the benefits of using like these big, like these already established services is that they're available, and they've like engineers that like are professionals and like actually know like have a lot more experience in sort of doing this sort of thing work on this. So these services are very secure. They're very reliable, so it's a good idea if if we have like large amounts of large amounts of data that we want to store that we can't necessarily store safely on our own. So this is sort of like the workflow of how it would work, us storing an image. So we are the client, and we send a request to our app, our server, with the image, and then we ask the cloud-based storage, hey, this is our image. And then they give us in response an image URL. So the cloud-based storage has our image, and they give us a link to access that image. So now our app has that image URL in our database, and this is what it looks like. So instead of having like a path, like a local file path, like to where our image is stored on our computer, it has a link to the AWS server. So now if our servers crash, we can still access those, like one of our servers crashes, those other servers can still access that image. It's not completely lost to us. And it's a lot safer because it's stored in a more reliable place. And so like using a cloud-based storage is a lot more, is a much better idea than having it stored locally on our own thing. And so what we will be doing next in our demo is using a cloud-based storage to store images for our own projects.
Hello everyone. So I hope you learned something from the lecture. Joseph and Maria did a really great job. I feel like I learned images like once again. That was a really good job. So yeah, we just want to thank Joyce and Maria for taking the time out of their day. We just like sort of asked them last minute to sort of do this, and they did a really great job. And yeah, we want to thank y'all for your hard work and taking the time on a Monday night to come out here. So everyone should give them a round of applause. Yeah, before we move on to demo, do they have any questions about anything? Okay, cool.
Hello. Okay. Okay, can people in the back hear me? Are we good? Awesome. All right, so again, that was a great lecture on how images work, right? We have three alternatives on storing images, but we're gonna be using a cloud-based service, which is much more secure than anything we're probably going to build by ourselves or as app dev groups or hack challenge groups. So I just wanna quickly demonstrate what we're going to be building today. Here's a service that converts an image to base 64 strings. So what this means is it kind of encodes your image into a string, and sending this across the network and like in through a request is a better alternative than just sending the file directly. So we're first going to be doing that, sending a request to AWS, and then AWS will give us the URL, and we'll take a look at that URL to see if it was actually uploaded to our server correctly. So in my Finder, I have a file that I am going to be using today. This is me playing baseball when I was like 4 years old. Okay, not actually, 4th grade or something. So we're going to be converting this into a base 64 string. Oops, that's my CB homework. So let's drag this in here. And you can see that this image actually got encoded into a base 64 string. So instead of passing in a file, right, because how would you do that here? We're going to be passing in a string. And that string, again, can be accessed through this URL, if you guys want to take a look at that. So I'm just going to go kind of click copy image. Sorry if that's a little hard to see. There's a button right here called copy image. And if I paste this, it's going to be a huge string that basically has every information about the image I just uploaded. Obviously very, very long. And we're going to be sending this to the server, which will then return us a link to that image. So if I actually copy this and paste this into my browser, you can see that an image is downloading. And if I click here, I can once again see that image. So this is what your front end is essentially going to be doing. Your front end developers are going to be sending a request to your backend. The backend will return the URL, and then the front end will then kind of download that file and store display it on their front end. So that's how images is going to work today. So how do we go about doing this? Well, obviously, we have to be using a cloud-based service called AWS. So let's first go to AWS, just look up AWS, and then it'll be the first link. Also, forgot to mention, the starter code is on the textbook. So if you just go ahead and go to images and then demo, the starter code's right here. Cool. So now that we're on the AWS website, hopefully this is what everyone sees. We can sign into the console. And I already have an account, but for those of you who don't, maybe we can spend like a 3-ish minutes setting that up. So you can just click on create new AWS account and use your Cornell email as I am doing. Okay, CAPTCHA. Okay, who here is trying to follow along demo today? Okay, and all right, we can give everyone a couple of minutes to set this up then. In the meantime, I will open the starter code on my VS Code. Okay, I hope the majority of you were able to sign up. I'm just gonna go ahead and get started. If you are still making your account, just ask a neighbor on what I did so far, and then hopefully they can get you caught up. So now that we're logged into our AWS Management Console, the button we have to click is under Services. Once you click on Services, you scroll down. There is a tab that says Storage at the very, very bottom. We click that, and then we click on S3. So like Maria mentioned, we're going to be storing our images on Amazon S3, which are kind of like containers for all of our blob-like files. And this is a bucket that actually is currently holding the picture of me playing baseball from a while ago. But we're just going to go ahead and make a new one just to demonstrate this to you all. So let's click on Create Bucket. And let's call this images demo Shango or something. This name has to be unique to your region, so it might be pretty hard to find a bucket name if you use like a very generic name. For the region, we can just stick with what I have right now, US East 1. And then, people are caught up so far. Let's scroll down. The only setting we have to change is this setting right here. So I'm going to zoom in a little. This is saying to block public access settings for this bucket. Now, traditionally, you would want to block public access so that people can't just like randomly upload files to your bucket. But for the sake of demonstration purposes, I'm going to turn this off. And it is asking me if I acknowledge that I'm being stupid, and I'm going to say yes. And then let's create the bucket. So now we have a newly created bucket called images demo Shango that is publicly accessible. Cool. Is that good so far? Good. All right. Next, we need to have a way of accessing this bucket. Now, there's several layers of security on kind of accessing service like AWS or Google Cloud, et cetera, et cetera. And that layer of security for AWS is going to be secrets. So we need credentials to be able to access this images or this bucket, because otherwise, literally anyone in the world can access this bucket, right? And we don't want that. So the way we can make a set of credentials is to click on my username on the top right and hit security credentials. And then we can go to access keys and create an access key. Now, I'm just going to go ahead and click create a new access key, and I'll show what my values are. These values are secret values. We do not want to ever be sharing this on the internet or uploading it to AppDev YouTube channels, which is what I'm doing today. But I'm going to be deleting this immediately after demo because I don't want people accessing my AWS services. Now, question for the audience: where do we want to be storing these values? Hands. It's in a file. It's in a specific file. Yes. Exactly. Thank you. We want to be storing these values in a .env file, right? Environment variables file, so that we don't have people externally being able to see these values. So with the starter code open, I'm going to create a .env file. And we're going to have 3 keys for it. One of them we're going to call S3 bucket name. This is so that, for us to be able to access our bucket, we need to know the name of the bucket. And there's literally no reason for us to be publicly sharing that, right? Like, why do we need our users to know what the name of the bucket is? So we'll make that a secret value as well. So I called it images-demo/shingo. And then the next 2 are the 2 values that I generated from the credentials management screen. So the access key ID and the secret access key. The key name for both of these values is AWS_access key_ID. And the next one is AWS_secret_access_key. Also, I just realized I forgot to turn on my video, so I'm going to do that. Okay. Did I start recording this? Okay, I did. Awesome. Okay. So hopefully you have these 2 copied down now, and we can go ahead and paste this into the access key, and paste that into our secret access key. And again, we don't want to be sharing this to the web, right? So we have to make a dockerignore file and add a .env file here. I think a good number of people missed points on the deployment assignment because they forgot to include the .env file in their dockerignore. But once again, we never ever want to be pushing our .env file to GitHub, Docker, or any online services. So let's make sure we have that. And then in our dockerignore file, we also need to add a couple other things. The first one is our virtual environment. The next one is our PyCache. And then the last one is our database file. Now, the database file is going to be defined in our app.py. So this has been the case since, I think, demo/programming assignment 2. But it's defined right here. So make sure you dockerignore this file specifically. I think a number of submissions also were like, they dockerignore todo.db, which was the one we use in demo, as opposed to cms.db, which is the one that was actually in the assignment. So make sure you're docker-ignoring the right .db file. Cool. Awesome. With that done, let's create our virtual environment. So the requirements.txt this time around is pretty big compared to previous demos. So I'm going to go ahead and make a virtual environment and install all of these dependencies. Okay, and then we can do .env 8 and install. All right, while we wait for this to happen, let's kind of go through what our code actually has, like our starter code has right now. All right, so we have our app.py. We have our generalized success and failure responses. We have a hello world endpoint, and we have an upload endpoint, and that's it. So this is actually the only endpoint we're going to be implementing this week, right? All we want to demonstrate is how we can upload images to the web. So this is the endpoint we're going to be using. And then in our db.py, we basically have nothing. This we will be coding up from scratch. OK, so let's activate my, oops, already activate my virtual environment. OK, awesome. So now that's done, we can start coding. Fun. All right, so we're going to have to do a lot of importing libraries. So yeah, this is going to be kind of busy work, but we have to import base64. We have to import Bodo3. We have to import datetime. We have to import IO. From IO, we have to import bytes IO. We have to, from MIME types, import guess extension and guess type. I already wrote a couple of them down, so let's just go over what each of these are going to be used for. So base64 is obviously going to be a way for us to be able to understand what's being sent from the front end, right? The base64 file or string. Bodo3 is our library for accessing AWS. Datetime is to get the current time, right? If you look at the response body I got from uploading this, I have a field that was like, when did it get created? So that's what the datetime is for. This is input output. You don't have to worry about this too much. This guess extension thing is going to be pretty important. So if we want to support, say, like only PNG files or only JPG files, then this guess extension thing, function, will be able to guess the type of the file when we just send it in as a base64 string. Okay, hopefully most of you got a lot of these copied down, so I'm going to move on. We have to import OS, right? This is for accessing environment variables. Import image. Don't worry about this too much. We have to create an image object when trying to upload it to AWS. Random is for creating a random name for our file. So if you noticed, the file that was actually generated has a very random string as the file name. This is because we don't actually want to be storing any sort of user information in the in these file names in the case they get compromised, right? It doesn't really matter what these are called, so it's just going to be a random string. So that's what random is for. We're going to be importing RE, which I don't actually know what it does, and then string, which is for cool string manipulations that we can do in Python. Cool. So with all these imports out of the way, let's define a few constants. So the first one is what extensions we're going to be accepting. Let's accept PNG files. Maybe we'll accept GIF files, JPG, and JPEG. So these are extensions we're going to be accepting. The base directory is going to be os.getCWD. So this is basically doing the same thing as PWD, which I've demonstrated several times, but it just prints your working directory. And the reason why we need this is because for us to be able to access files within our code, we have to give our Python code the absolute path to that file. So that's why we need this base directory constant. We need the S3 bucket name. So this can just be loaded from my environment variables. Right, we defined that right here, right, S3 bucket name. And then the last constant is the base URL. So this is just something that AWS has defined for us, but the link we're going to be using is going to be in this format. It's going to be https://s3 buckets name .s3.us east1, which is the region I'm actually in my AWS console. If your region is different, it might be a little tricky to do this. So if you look at my URL right here. It might be hard to see, but it says US East 1 on the top. And then .amazon.aws.com. So that's the URL we're going to be pushing all of our images to. By the way, this string format, I think Kate mentioned last time, but in case you didn't catch it, from maybe for those of you who haven't taken 1110, this is called, or I don't actually know what it's called, but F strings. You can kind of insert variables within your strings just by wrapping them in curly braces, as long as you have an F preceding the string declaration. So for last demo, I was actually supposed to do hello and then like os.enderon.get name as an F string, as opposed to doing hello and then like a plus and then the thing I did. This is better Python practices, but yeah, hopefully just keep that in mind. Okay. Now we're going to be making a model for our images. The model name is going to be asset. And this is a db.model. So we call lecture 4 for this. And we'll just say that this is an asset model. Hopefully this doesn't give you flashbacks, because it was notoriously the hardest assignment probably this semester. But the table name is going to be assets. We have an ID field, which is db.column, db.integer, primary key equals true, auto increment equals also true. And then we have a base URL, db.column, db.string. This is going to be the base URL of our image. So that's this bit right here in the URL. It's the HTTPS demo 8 bucket, blah, 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 blah. Like all this is always going to be the same, so we want to be storing it in a variable. And then we have salt, which is our way of making randomized image names. We covered this last time in authentication. We have an extension, which is saying, is it like a .png, .jpg, whatever. We have the width of the image. So if you ever want to use this information during your hack challenge, you can do that too, right? So if it's like over a certain size, you want to display it one way, kind of something like that. Integer nullable equals false. Also, you can just like copy and paste each of these lines. I'm just typing them out in case people are struggling to catch up, but yeah. And then we have a created at field, which just tells the computer when this file was created. So this is going to be a data type date time, which is actually supported in SQL Alchemy very pleasantly. Yeah, so these are going to be our fields for images. You can see people are still copying this down. So maybe I'll wait a tad bit. Most of these lines are the same, so you can just like copy and paste and change maybe the data type and the variable name. All right, let's move on. So when we create an asset object, we want to initialize it, right? So we need an init function just like we have. We needed one for everything across PA4 and demo 4 boards. Initializes and assets documentation. And when we create a new image model or an asset model, we kind of just want to like go ahead and create that image and like upload it to AWS. So instead of just, like we want to be defining all of these fields, so we'll create a few helper functions on how to on doing that. So the first thing we'll do is creating the image, and we'll just make a new function on creating the image. which will take in self and the image data, which is the image in base 64. And what this create function will do is, given an image in base 64 form, does the following. So it does a few things. The first thing is it rejects the image if it is not a supported file type. It will then generate a random string for the image file name. Thirdly, we will decode the image, and attempts to upload it to AWS. So we'll wrap this all in a try-catch. It's generally nice to wrap things in try-catch if you don't know if it's going to succeed. So something like image upload to AWS is something that's potentially likely to fail. Like if, let's say, AWS goes down, that's not entirely our fault, but it might give us an error, and we don't want our app to crash in case of an error. So we can catch that exception. So what do we put in our try statement? Well, first, right, the first thing we want to do is reject the image if it's not a supported file type. So we can guess the extension of the file that was passed into us by using the guess extension function that was passed in through the MIME types library. We will pass in guess type. So this is just a lot of syntactical stuff. Oops. Oh my God, all my extensions are popping up everywhere. But this is overly verbose. Just write it once and copy it for hack challenge if you like to use images. But this line essentially just takes the extension of the image. So whether it be like PNG, GIF, JPG, or JPEG, that's what this line does. So we will only accept the image if it's a supported file type. So if extension is not in extensions, which is the constant that we defined up here, it's a list of extensions that we defined up here, then we will raise an exception that will read unsupported file type, and we will pass in the file type that was unsupported. So make that an F string. Don't forget the F up in front here. And we'll complain that this extension type was not supported. If it was supported, then we want to make a name for the image. So we will here way of generating a random string for image file name. So that's what we want to do, right? Step 2 is to generate a random name for the image. So we will make a salt. This is another case of just copying this code when you want to make a hack challenge. But in short, what this is doing is it's using a combination of uppercase and numerical characters to make our file name. And then once we have a file name with this given salt, we want to decode, right? We want to decode the image and upload it to AWS. So when we pass in a base 64 image, there's this image or data image string preceding the image data, and all the way at the very end. Actually, no. Oh yeah, and then it says data image, and then it says base 64 right here. So here's where the image data, or like the information about the image, actually starts. So we want to cut this part out of the string. So the way we do that is doing header of base 64 string. The way we do that is through this thing called regular expressions. You may have heard that kind of buzzword in like CS classes, but you'll learn about it a lot more later if you end up taking higher level CS courses. But this essentially just strips the data image and the base64 part out of your string. It's, again, a bit verbose, but hopefully y'all can kind of deal with it and just like copy it down. So this is saying, I want you to substitute, this is what sub is short for, all this, which is saying data image, any string that starts with data image ends with base64 and everything in between, which is this part right here. And I want you to substitute it with an empty string. So just get rid of it, is what it's saying. Trust me, this part is, I know, again, very kind of confusing. But image upload will be much more fun when we start setting up the bucket and everything. So image data is just, so this is basically, this variable, we wanted to actually store the image and convert it from the base64 form to the actual image form. So the way we do that is by doing base64, which is the library name, and calling the function b64 decode, and then the image string. So this converts it from the string to the actual image as a file. Finally, we will store the file in this variable by converting it from a binary data, which is what this decoding thing does, and storing it as an actual image object, which is understandable by Python. Okay. Cool. Now that we've done that, we want to be setting all of these attributes. So this will be a lot of copy and pasting, but self.base URL is the base URL that we defined as a constant. Self.salt is a salt we just created right here. Self.extension is the extension, right, variable that we extracted up here. Self.width. Now that this img thing is an image object, we can query the width just by doing .width. It's now a parameter within the image object. Self.height, same thing, image.height. We have self.created@. And we can just assume that when we initialize the asset object is when we are creating it. So we'll just do datetime.now. Image file name will be another f string, self.salt.self.extension. So back to this example that I used earlier. The string that was actually used for this file name is this. Right, so a bunch of characters, uppercase, and a bunch of numbers kind of jammed into a string, and then the .png, which is the extension of our file. So that's what this is doing. The salt generated earlier is this part. The extension is this part. So go ahead and copy that if you'd like. And then finally, we will try to upload it to AWS. So we'll make a function called upload and pass in the image object and the image file name so that we'll know how to call it, or like how to name the file when we upload it to AWS. If we catch an exception, we can just print an error. It says error when creating image. We can pass in the error which we've caught as E. Okay, so that is about all we have time for. Next time we will be implementing this upload function and actually calling or creating an asset object in our app.py. But that is images for today. So before we move on to Kahoots, any questions? Okay. Next time I might upload this so that people who don't come today can still partake in Wednesday's demo.